Okay, so I had a few technical difficulties uploading that, so I'm just going to redo this. So this is 2018 8C. So what we have here is you're asked, explain clearly why the boiling point of propanal is much higher than butane. So propanal is a member of the aldehydes group. Okay, so what we're looking at here is the functional group of C double bond O. Where do you go? You go to page 81. Your electronegativity of oxygen 3.44, carbon 2.55, so an electronegativity difference there 0.89, butane, carbon 2.55, hydrogen 2.20, electronegativity difference there 0.35. So my propanal there has dipole-dipole forces, whereas butane only has the van der Waals. Next, then you're asked why the boiling point of ethanoic acid is higher than propanal. Okay, or sorry, propan-1-ol. So if we look here, they both contain hydrogen bonds. Okay, so oxygen bonded to or hydrogen bonded to oxygen, nitrogen, and fluorine. But if we look here, the COOH actually can have two hydrogen bonds, whereas my OH functional group only has one hydrogen bonds. You would also get in your marks for just saying stronger hydrogen bonds. Just to explain this, remember when we're talking about bonding, van der Waals, dipole-dipole, and hydrogen bonds, it's between molecules. So if I look here, C double bond O, that can create a H bond with another carboxylic acid, and likewise down here. Okay, so that's your two areas for a H bond, whereas over here in my ethanol, or sorry, in my alcohol, only OH there, so can only form one other OH bond here. Okay, so between forces, so only space for one. So that's where you get that. We'd have looked at that in class. Remember, the two H bonds is called a dimer. Part D, the organic product of the reaction of C, and C we're told is propanal. Okay, but if you look at what we did, we started off with a primary alcohol when we looked at oxidation. It goes to an aldehyde, and finally it will go to a carboxylic acid. So when I react or do any of my tests with my aldehyde, the reason why it turns them colourless or whatever the result might be, right, would be because they can actually be further oxidized, and in this case they're further oxidized into propanoic acid. Okay, so that is what you're looking at there. Okay, so answer there is propanoic acid. Okay, and then finally then E, write the balanced equation. Okay, so if I look at B is propan-1-ol. Okay, so OH here, carbon of the OH group attached to one other carbon. I just drew it out to make it a little bit easier. So we've 1, 2, 3 C's, so C3, and then 1, 2, 3, 4, 5, 6, 7 H's, and remember we always keep our functional group the same, so that's OH. We're reacting that with sodium, and we end up with sodium ethanoate. Okay, so again here, this is where my my propanol will react as an acid. So it will create a salt, and here then we have hydrogen gas producing. Remember, anytime a metal and an acid react, we end up with hydrogen being produced. So then just to balance, I have two H's here along with the CH or C3H7O. So I need to have two H's here, so I have to put the two here. Then if I look, I have two C3H7O's, so I need to put the two here to give me that. Then if I look here, I have two NA's, so I need two Na there to balance.